Hello again, everyone. So the next topic for us in the series of how to crack the ST math portion is today going to be solving linear equations and inequalities. So in the last lesson, we had learned about what linear equations really are, what they mean in context of a line, how do you find the equations, and what really each piece of the equation means, right? So for the next section, we'll talk about how we really are able to solve these linear equations, and we'll go into a little bit of inequalities and understand what those are. So just to give an initial context on this, let me just go ahead and here. So last time we had talked that the equation of a line or linear equations is something like y equals 2x plus 3, y equals mx plus b form. This is the general category. Now, say I want to start learning about how do I solve these kind of linear equations. If I'm given more than one linear equation, how am I going to solve it, and so on. So we need to go back and revisit our uh, previous topics that we've learned about how do we distribute items, how do we add and subtract like terms. So very important concept, like terms. You can only add or subtract like terms. You can only add or subtract if they're like terms. Again, a very important concept. It's simple, but very important, and I've seen people make mistakes on this. So just remember this, like terms, you can only add or subtract them if they are like terms. So for example, 2x plus 3x, this is something I can add and make a 5x. But if I have 2x plus 3y, there's nothing I can do. I end here. That's it. So how do we really go about solving linear equations? Just to give an example, right now this is a linear equation with two variables. I could have linear equations with one variable as well. So just to give a quick example, let's say I have an equation which is something like this. 3 times 1/2 minus y equals 3/5 plus 15y. So in this case, we'll learn about a couple of strategies here. One is distribution. Distribution means you can use the method of FOIL, where you multiply the outside term of a parenthesis with all the terms that are inside. So I'll just start with that. So this would become 3/2 minus 3y. The other side, I'm not going to touch it at the moment. The next piece of it, we want to make sure we add the like terms, and the unlike terms, you cannot do much about it. So if you see at this point on both sides of the equation, we have unlike terms like 3/2 minus 3y, I cannot do anything with it. 3/5 plus 15y, I cannot do much with it. But what I can do is I can try to bring all my y's on one side. So very important here, and I'll emphasize this time and again, you want your variable terms to be on one side. And how do we achieve that, right? So I'm gonna add 3y on both sides. So when I add 3y to the left side, I'll just write it here, plus 3y here, plus 3y here. I can cancel out the minus 3y and the plus 3y, and I am left with 3/2 equals 3/5 plus 18y. You can always add or subtract or multiply or divide a number on both sides of an equal to sign. That does not change your equation. So remember, you can always, again, I'll say this again, add or subtract if it's the same number on both sides of the equation and it does not change anything. So in this case, I added 3y. And again, variables, they're numbers at the end of the day. We just don't know the value of it. So I added the 3y, but now I'm still left with 3/5 along with the 18y. So I want to make sure that I have my variable alone. So in this case, I'm going to subtract 3/5 out and see how I'm doing the opposite action in order to eliminate a term from one side. Since I have a positive 3/5 on the right side, I'll subtract the 3/5, which will take the 3/5 out from the right side. And why did I do that? Because I want the 18y to be alone on one side so that I can treat it separately. And when I do 3/2 minus 3/5, again, just a refresher on fractions, 3/2 minus 3/5, you need to have a common denominator. And in order to have a common denominator, you can use a like fraction, right? So 3/2, I can also write it, if I multiply the numerator and the denominator by 5, I can also write it as 15/10 minus 6/10 for the 3/5. So I'm left with a 9/10 here. And finally, I can say that 9/10 is equal to 18y. I can use the method of cross multiplication, or I can just say, since the 18 is multiplied to the y, I want to do the opposite action and divide both sides by 18. Now remember, when we do 9/10 divided by 18, it's the same as writing 9/10 times 1 over 18. The 9 goes into 18 twice, so I'm just left with 1/20. 10 times 2. So my final answer here becomes y equals 1/20. So that's how we solve a linear equation on one variable. Similarly, we have other situations where we might have two variables and we want to solve a system of equations with two variables. Before that, I'd just give one more example with the one variable solution. Now we use the variable y, there could be variable x as well. So let's try a question with that. Minus 2 times 3x minus 2.4. You can have decimals as well. Minus 3 times 3x minus 2.4. So again, distribution. I'm going to do both the distributions at the same time. Minus 2 times 3x minus 6x. One important thing here, now the second distribution, we're going to have a minus minus sign, which means minus minus will become positive. So be very careful with the signs. Minus 2 times 2.4 will give me a plus 4.8 because of the two negative signs. Negative 3 times 3x is negative 9x. And again, the same situation. A minus minus gives me a plus here. And 2.4 times 3 is 7.2. Now, time to bring the variables on one side. So I'm going to add 9x on both sides for this one. I'm left with 3x plus 4.8 equals, this cancels out, 7.2. Subtract the 4.8 to get the x alone. And I'm left with 3x equals 2.4. Finally, divide out the 3. All I'm doing is opposite actions to get rid of every term that's with x. I want the x to be alone. X is 0.8. And that'll become my final answer. With that said, the last thing that I want to cover in terms of solving linear equations is how to solve linear equations with two variables. So we have an example here. Let's say negative 2x is equal to 4y plus 6. And 2 times 2y plus 3 equals 3x minus 5. All right. So this is where we can be using two different methods in order to solve this problem. The first method is what we call substitution. So I'll start with that, and then we'll slowly go over to the method of elimination. So I'd like you to write this down as I do it. It always helps to write the problems along with looking at the videos. So the first thing here I'll do is substitution. I'll take this first equation, and let me change the color of the pen so we can see it clearly. I'm taking this equation number 1. I'm saying that I'll just divide the full thing by 2. Again, remember what I said, I can divide, multiply, add, subtract the same number on both sides as long as it's the same number, and I'm doing the operation on both sides of the equal to sign. So I'll divide by negative 2 here, and I'll rewrite that equation as x equals negative 2y minus 3. Be careful of the change in signs. Because I'm dividing by negative 2, it all gets divided across. So this is my new equation. I know x is negative 2y minus 3. I'll use this fact, I'll call this number 2. I'll use this and substitute the x up here. And how will I do that? So let me show that to you. The first thing, distribution. 2 times 2y is 4y. 2 times 3 is 6. So 4y plus 6 equals 3 times. Instead of x, I'm going to write negative 2y minus 3. Be careful of the parentheses again because we're substituting the whole y the whole x, make sure you put the parentheses in because this x is being substituted fully by negative 2y minus 3. And then I'm also still left with the minus 5 that's in the question. Next, 4y plus 6 equals 3 gets distributed here. 3 times negative 2y, negative 6y, again being careful of the signs. I'm sorry, I'm repeating it multiple times, but this is where the most mistakes happen. 3 times negative 3 is minus 9, minus 5. Now I'm left with 4y plus 6 equals negative 6y minus 9 minus 15. It's minus 9 minus 15. It's not 9 minus 5. It's not 5 minus 9. When you have two numbers, both with negative signs in front of them, you add the numbers, but you put a subtraction sign in front of it. So this is negative 14. I shouldn't have written 16 there. Just correct that. And this is negative 14. All right, I'm in a good position now. So now I can start adding 6y on both sides. That gives me 10y plus 6 equals negative 14. Subtract the 6 out on both sides. I'm left with 10y is equal to negative 20. Negative 14 minus 6 is negative 20. And I get y is equal to negative 2 because I divide out the 10. And then I divide the 10 here as well. All right, so we're now left with y is equal to negative 2. So finally, I'll go back, change my color here. I'll go back to this number 2 here. I said y is equal to negative 2 and x is equal to negative 2 times y, which now is our negative 2 minus 3. Minus 2, when multiplied, give me 4. So 4 minus 3, and that gives me x as 1. So my solution in this case becomes x is 1, comma, negative 2. So I hope that made sense, and that pretty much sums up how we solve our linear equations. And this gets us to linear inequalities. Linear inequalities are really very much similar in terms of solving equations on how we did with the system of equations here. Actually, before I move to that, let me cover the elimination method as well. We did substitution last time, and there is another method. Now, this is the method I actually prefer over substitution most times. So it's totally dependent on the student, what they're comfortable with, but I definitely recommend doing the elimination over substitution all the time. So just to give you an example, the question that we had before, and this time I'm going to just write it with no parentheses. It was negative 2x equals 4y plus 6. And then the other equation was 4y plus 6 equals 3x minus 5. So what I'm going to do in this case is I'll just rewrite this equation below the other one. So I'll say 4y plus 6 equals negative 2x. So this is my equation 1. This is my equation 2. I'm going to subtract equation 2 from equation 1. And when I do a subtraction, every sign flips. So every negative becomes a positive, every positive becomes a negative. So in this case, when I do 4y minus 4y, it's a 0. 6 minus 6, it's a 0. So I'm left with a 0 on this side. This is 3x plus 2x, so 5x minus 5. I add 5 on both sides. I get 5 equals 5x, which tells me x is equal to 1. Much simpler to get the answer when we do the elimination method, but the hard part is to make sure that you arrange your equation in such a way that you can easily eliminate. It's called elimination because we're trying to have variables with the same coefficient, and then we are trying to eliminate them from the equation. Now that x is equal to 1, again, the same method, I can put it in, let's say, equation 2, and say 4y plus 6 equals negative 2 times 1. 4y is equal to negative 2 minus 6. I did 2 steps in one go. I multiplied the minus 2 and 1, and I subtracted 6 on both sides. So 4y is negative 8, or y is negative 2. Again. Just one more quick thing on the elimination method. Let's say I have a question like 2x plus 3y equals 7 and x minus, let's say, 2y equals 5. In this case, to do the elimination, we need to make sure that the coefficients of the two equations, at least one of the coefficients, whether it's the x coefficient or the y coefficient, and when I say coefficient, it's the number besides the variable, at least one of them has to be the same in both the equations. So in order to make that happen, I'll multiply this whole equation by 2, rather negative 2. So I'll rewrite both the equations with 2x plus 3y equals 7. But the second equation now becomes negative 2x plus 4y, negative 10. Signs flip because of the negative sign. I'm multiplying a negative 2 to every term in the second equation. What does this do? Now I can simply add the two equations. 2x minus 2x is a 0. 3y plus 4y is 7y. 7 minus 10 is negative 3. And so y is just negative 3/7. So a very important thing again to remember when you have equations that you need to solve. If you use elimination, you have to make sure that your variables are the same, have the same coefficient rather, so that you can add or subtract them out. If you're doing substitution, you need to have one variable alone on one side, get an equation with that variable, and then substitute that variable into another equation to get your answer. So with that said, the last topic right now is inequalities. Again, very similar to what we have learned so far. And we'll try to solve the inequalities here. So let me go ahead and take an example for the inequalities. So in this case, I'll just refer back to a question that I had in the study guide, the College Board study guide. Again, a lot of these questions that I'm doing are directly from the College Board study guide that they have released. It's the official board, and I like to do the questions from there because they're the closest we can get to an SAT. So in this particular question, we have the information saying that John is jogging at 6 miles per hour. I'm actually going to go back to the official study guide and show the screen here from there. All right. So each morning, John jogs at 6 miles per hour, rides a bike at 12 miles per hour, and his goal is to jog and ride his bike a total of at least 9 miles, no more than 1 hour. So the important part here is to make sure that you write down your pieces of information as you see it in the equations or in the question, right? So John jogs at 6 miles per hour. So jogging is at 6 miles per hour. Biking is at 12 miles per hour. He wants to go for at least 9 miles. Now, in order to get miles out of miles per hour, you have to multiply time, right? Because miles per hour, only if you multiply with an hour, you'll get the miles back. So you already know that this has to look like a multiplication question. It cannot be a division question, or it can be, but let's go through the whole thing and see if we can find out from the equations here. So right now we're saying that he rides at least 9 miles, which means if he's going j miles with the jog, which the question says he jogs for j miles, and the biking is for b miles. So the total of those miles should be more than 9, greater than or equal to 9. So j plus b has to be greater than or equal to 9, which eliminates option C for us. So I would say j plus b has to surely be greater than or equal to 9. And he wants to complete his goal in no more than 1 hour, which means that the timing has to be less than or equal to 1 hour. So how do we calculate time? The number of miles he travels divided by the speed. Now remember, speed is distance over time. So if I were to calculate time, I would say it's distance over speed, which means in this case j over 6 plus b over 12 has to be less than or equal to 1 hour. Now remember, it's less than or equal to 1 because it's no more than 1 hour. That's why it's less than or equal to. The wording is very important here. So now I have both my equations. I compare it with the question. only choice A makes sense. So inequality is very important for us to remember. When they say no more than, it's less than equal to. When they say at least, it's greater than equal to. The wordings is what will drive your signs. Another thing, when we solve linear inequalities, we need to make sure that they both have either the less than equal to signs or greater than equal to signs together. Let me go ahead and actually show one question here for the inequality. So in inequalities, we will just cover this here. Let's say I say x plus y is less than equal to 5. If I were to multiply this whole equation by -1, then it would become negative x minus y is greater than equal to -5. When you multiply or divide by a negative number with inequality signs, the sign flips. So that's again another important concept with linear inequalities. It's nothing but the same as system of equations, except that it has this less than or greater than equal to signs in between, and that depends on what the question is asking you. So depending on that, you'll put your signs. Let's say I were to solve two linear inequalities. X is greater than equal to 5, x minus y is greater than equal to 7. On a graphical terms of view, actually let me make that one less than equal to 7 so that we can see it better. If I were to graph this, x is greater than equal to 5. Greater than equal to 5 means the x is not changing. This is my x equal to 5 line, because let's say x is 5 here. Everything after this is shaded because x is greater than equal to 5. If I were to say, and I'm going to make this even less than, so first thing I'll need to do is plot x equals y plus 7. X equals y plus 7 is, for now I'll just draw it roughly, it's somewhere here. And since I've said everything is less than, so one thing that will happen is there will be dotted lines here. That's how you graphically show less than, since it doesn't have an equal to sign with it. So everything below it becomes my solution. So that's how you graph these linear equations. That pretty much covers everything from an SAT perspective. Obviously, there is a lot more to learn in linear equations, but learning at least this much would help with all the questions that you need to tackle with the SAT. So finally, I'd like to close this off with a couple of very well-known concepts that SAT tests you on. So just to give one example, right? If we have an equation, something like 2y plus 6x equals to 3 and y plus 3x is equal to 2. If you look at the top equation, if I divide the top equation by 2, I get y plus 3x is equal to 3 halves. But my second equation says y plus 3x is 2. So whenever this situation occurs where this side is different, but this side is same, that's when you have no solutions. If they ask you such a question, the answer for this would be no solutions. But at the same time, if I change that question to say 2y plus 6x is equal to 4 and y plus 3x is equal to 2, I want to solve these two equations. I divide again this whole thing by 2. I get y plus 3x is equal to 2, the exact same equation as the second one. This is the situation when we have infinite solutions. Two very commonly asked questions, no solutions, infinite solutions. So you need to know the difference. In infinite solutions, both equations essentially become the same when you divide or multiply a number. In no solutions, the right side is going to be different, but the left sides are going to be the same. That should be it for this particular section. Again, as we go further in these lessons, I'll be doing some tests at the end where we'll also cover some real SAT questions that have already been presented in some tests in previous tests. But at this time, I think this is enough information to get everyone well acquainted with linear equations in terms of what SAT asks. So thank you again for watching. Please don't forget to like and subscribe for the channel. Thank you.